It's at this point that you can start getting technical, by which I don't even mean writing any SQL yet. I'm still several stages away from that. Now it'd be a good idea to create an entity relationship diagram. The idea of entities is a common one across various different disciplines within programming and software design. If you've done any programming before, you'll be aware of the object paradigm and the structures of object-oriented programming. With a relational database management system, our entities are rather different to the objects within object-oriented programming languages. However, they do have some similarities. Each of the objects should be a single item within our database, and we should try to stick as closely as possible to real-world entities. For instance, we may wish to create an entity called a book, and in general, our entities within our entity relationship diagram will translate directly to tables within our database. There are some specific ways to create an entity relationship diagram, some ways of drawing lines to represent the relationships between entities. You can follow these if you wish, or you can use your own method. It doesn't really matter. So long as you understand and you're consistent about the way you're laying out your diagram, that's the main thing. Most important thing about entity relationship diagrams is that all entities that are going to be included within your database are mapped out in your diagram. For instance, we may have a book entity and a publisher entity. We also need to specify the exact way in which they relate to each other. We draw lines between each of the entities that relate to each other, and then in some way we annotate these lines to show the particular kind of relationship it is. It's usual to put a crow's foot or extra little lines there if we want to show a one-to-many relationship. If it's a one-to-one relationship, we simply put a single line. We can also use a circle to indicate that the relationship is optional on the part of one or other of the entities. That is to say, a publisher can exist within our database that hasn't published any books yet. This allows for all kinds of different theoretical eventualities. We put the circle on the side of the book because the publisher can exist without the book, but no book could exist without a publisher. Similarly, we put in genre entity within our entity relationship diagram. However, there's a slight difference here because genres can exist for which we have not yet entered books into our database, but we can have books that defy genre, books that refuse classification. Therefore, I'm including an optional, a little circle there to show that it's optional at both sides of the relationship. However, it's still the same kind of one-to-many relationship. One genre, many books. We could go further and complicate that to say that a book can cross between two genres, but I think that's better exemplified by the author entity. Now, we could simply put a one-to-many relationship there, or between books and authors, but that would only allow books to be written by one author. Now, that is not a rule that we can impose on our library, especially if we're going to be using technical or non-fiction books, many of which are written by more than one author. In order to represent a many-to-many relationship, as in any number of books can be written by more than one author, we have to use a bridging table. I've called this book author, and this is a way of implementing a many-to-many relationship in a way that can be used by our relational database management system. If you take a look at the SQL schema that is included in the source folder on this CD, you'll be able to find the particular tables that are included within this database. Finally, once you've made your entity relationship diagram and you're happy with the way it looks, then you can start to draw up your SQL schema. You'll find that as you implement each of these steps, as you draw out more and more technical diagrams and finally create the SQL, you'll find that you'll be constantly refining as you go. So you may draw up a first initial draft of your SQL schema, and then you may find that you will refine it, create different tables, alter the structure of your database, and so on. This briefly sums up the process by which we get from the conceptual point of the process to the actualizing of the database. In the next movie, we're going to look at normalization.